Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I want to introduce myself. My name is Winnie Septiani. I'm from Industrial Engineering, Trisakti University. I want to present our paper entitled Warehouse Layout Designing of Cable Manufacturing Company using Dedicated Storage and Simulation Pro Model. This presentation will be divided into 5 sections: introduction, literature review, method, result, and conclusion. PT Exeget is a company engaged in the field of cable production, which produce various types of cable such as electrical cable, communication cable, and others. The cables are stored in a warehouse in open or closed area. Large cables are wound in a haspa and stored in open area, and small size cables are rolled using a roll and stored in a closed area. The focus of this research is a finishing goods warehouse in open area. The finishing goods warehouse in open area is divided into 6 areas, and the type of haspa that is stored in the warehouse consists of 27 types of haspa with different type of size, laying of items that are still mixed, not grouped. This causes a long time to search for goods in the warehouse. In addition, the location of the warehouse is far from the location of packaging or shipping. The purpose of this study was to evaluate the layout of finished goods warehouse for haspa type so they can be grouped and minimize displacement time. The study used simulation design using Pro Model simulation and improved layout evaluation using dedicated storage methods. This research began by conducting a literature review on 2 main materials, including warehouse layout designing and simulation using Pro Model. Based on the result of literature studies, so the warehouse is a support facility that has important role in production system, and the previous study about simulation showed that Pro Model is also powerful simulation tools for solving manufacturing and service system problems. In this study, there were 5 stages in methodology conducting, namely the first stage, analysis of existing system, focus to finish product warehouse in the outside area. The second stage, designing the simulation model layout, the current system, divided into 5 stage, designing simulation model, rating distribution, verification, running simulation, and validation. The third stage, improve layout of the warehouse of finishing goods, use dedicated storage method. Fourth stage, evaluation of the proposed improvement warehouse layout, and the last stage, analysis of food system using ANOVA and LSD or least significant difference. Data collection was done through interview with operator and head of warehouse, direct observation to observe activity in warehouse, and historical data. Warehouse of finishing goods on the warehouse open area is divided into 6 areas, and the household moving flow start from the packaging area, are then moved to storage are using forklift. the helper requested from the warehouse will be moved to the shipping and the shipped to the customer. Analysis to existing system uh, so that material handling used in the warehouse use 3-unit forklift, and there are 27 different types of helper in the warehouse. After the testing simulation, after analysis of existing system, they are designing simulation model with from model consists structural element, operational element, and numerical data. Structural element simulation warehouse layout system divided into 4 elements: entities, location, resource, and path network. Operational element divided into 2 elements: arrival of the goods into the warehouse with input from the number of items in quantity H, and the process observed is the move of finishing good from packaging to area and area to shipping. Result for verification and validation show that the model simulation of the SAM actually and based on result and the calculation of half width, the result of the system and the simulation system is otherwise the same. Improvement of warehouse layout using dedicated storage. The result of improvement use dedicated storage follow calculate space requirement for every helper, calculate throughput for every helper, and the BGS value to the smallest, and calculate distance block. And calculation result with dedicated storage method can be seen in this table. And product displacement. Product placement is done by putting product to has a height on the location with the close distance to input output, and the next put the smallest on the location with the next close distance to input output. With calculation of dedicated storage, obtain some change in the location of the lying of goods in warehouse. Product placement can be seen in this table, and proposed improvement of warehouse layout with dedicated storage can be seen in these figures. Scenario for improvement design is made to determine the possibility of preferred solution warehouse layout. In this research produced to improvement scenario layout, the first scenario is the result of improvement warehouse layout based on dedicated storage, and the second scenario use the item laying calculation like scenario 1 with the addition of material handling unit. The addition of material handling is done on material handling which has the highest in use, and the material handling that was added was found in forklift 1 with become 2 unit. The simulation result show the time of moving goods in the warehouse of 129.145 hours. The evaluation of scenario improve can be seen in this table. The scenario based on the result calculation ANOVA test obtained value equal to F table. And conclusion in for this research, the first conclusion, the simulation result using from model on the current warehouse layout reduce product transfer time of 140.27 hours in amount, and this research has produced the proposed improvement. The first scenario result in improvement improvement warehouse layout using the dedicated storage method, and the second scenario result in improvement in the first scenario plus the addition of material handling tools based on highest percentage of utilities. The result of evaluation with simulation of the first scenario produced a displacement time 130 8.21 hours per month, while the second scenario produced a simulation time 129.0809 hours per month. The simulation output has been tested with ANOVA and LSD. The results show a significant difference between the two scenarios. Result of limitation. The key performance indicator used in this study is still limited on time and the utility of material handling. This result can be developed using the key performance indicator of the others, such as quality, cost, and productivity. In addition, this result also has yet to calculate storage space efficiency. Thank you.